Surd and Indices Practice Exam Question 20. Give the answer in the form of square root k. So we have square root 8 over 3 plus 3 over 2 square root 8 over 27. Now, our understanding of square roots is that when the whole thing's being square root, it's the same with our understanding of powers. It applies to the numerator and applies to the denominator. So I can rewrite this as square root 8 over square root 3 plus 3 over 2 times square root 8 over square root 27. Now, the first thing I want us to think about is let's look at our understanding of our first fraction. So our first fraction, I'll just scrap, is square root 8 divided by square root 3. So we are going to rationalize this because we don't want a surd on the numerator. So that means I'm timesing the denominator and the numerator by square root 3. Square root 3 times square root 3 is 3 over square root 8 times square root 3 is 8, 16, 24. So we've got the square root of 24. Now, I might as well have a go at simplifying this right now. So we look at our squared numbers and to see if we can simplify. So that means if I'm looking at them, we've got 2 squared is 4, 3 squared is 9, 5 squared is 25. So the only one that we can look at is 4, because 4 is a factor of 24. So the first thing I think about here is rewriting the question, because the square root of 24 is the same as square root of 4, 4 times 6. So square root of 4 times square root of 6 over 3, which is the exact same as me saying square root of 4 is 2, 2 square root of 6 over 3. So that is in the simplest form. Okay, and let's look at the second part now. So the second part is that we need to look at our square root of 8 and square root of 27. So the same thing applies here, is that we need to make sure that we are looking at the factors of 8, and 4 is a factor. So I can rewrite that as square root of 4 square root of 2. Same with my denominator. A squared factor of 27 is 9. So I can rewrite this as square root of 9 square root of 3, because 9 times 3 is 27. So we know the square root of 4 is 2. So it becomes 2 square root of 2 over square root of 9 is 3. So it becomes 3 square root of 3. Now that we've simplified it slightly, we also know that we do not want a square root on the bottom, so we need to rationalize. That means I am timesing the denominator by square root 3, and I'm timesing the numerator by square root 3. So square root of 3 times square root of 3 equals 3. So 3 times 3 is 9. And then I look at my numerator, I've got 2, and then square root of 2 times square root of 3 is square root of 6. So that leaves me with 2 square root of 6 divided by 9. The only thing that we haven't got now, I'm just going to make some space, is we need to finish our working out now. So let's go back to what we've got so far. We've got 2 square root of 6 plus 3 square root 2 times 2 square root of 6. So it's all about just working at it in parts. So now let's solve this. We can simplify this part by going timesing the numerators together and timesing the denominators together. 3 times 2 is 6. So we got 6 square root of 6. And 2 times 9 equals 18. And we're plussing it with 2 square root of 6 over 3. Now, to get the denominators to be the same size, I need to multiply. I could multiply my denominator here by 6, but also I'll look at my other fraction. There's 6 and 18, and they both have a common factor of 6. So I can just divide both sides, the numerator and denominator, by 6. 6 divided by 6 equals 1, cancels it out, and 18 divided by 6 equals 3. So now our denominators are the same. We're just adding 2 squared, 2 square root 6 plus square root of 6 over 3. So if I've got 2 square root of 6 plus square root of 6, that gives me 3 lots of square root of 6. And if I'm dividing it by 3, I'm just left with square root of 6. So my answer is square root of 6, and k must be 6.